right, so this is the last section, but we're going to do this one in 2 days. We can maybe do it all in one, but I felt like it'd be a little bit easier to do in 2. In the previous section, we talked about increasing and decreasing. So whenever you increase and then switch to decrease, that's actually going to create a maximum. When you decrease and then go to increase, that creates a minimum. So just to kind of give you an example here, we'll draw a picture. So let's say that we're going up and then we go down. That place where we switch from going up to going down is a maximum. If we're going down, decreasing, and then we switch to going up, that place where we switch creates a minimum. And that's essentially what those definitions there say. If we find the place where it changes, then we can find the minimum or the maximum. Well, we did that in the previous section. We found where it switched from increasing to decreasing or vice versa. So we're just going to add one extra step to that. Well, if we find out where it switches, what x value it switches at, we can plug that x value into the equation to find the y value. Okay. Now, a little note here, if f prime of x does not have to change sign at a critical number. If it happens, there's neither a minimum or a maximum at that number. So it could be that it kind of just pauses a little bit. That's not really something that you're going to worry about seeing, but just wanted to point it out there. So now some of the questions in your homework are just going to ask you to find a minimum or a maximum from a graph. Now the word local means that it's not necessarily the highest, because the highest would be the very tippy top. Well, in this graph here, the graph goes all the way up to infinity. That would actually be my maximum. So they call it a local. And minima and maxima are just plural of minimum and maximum. Now, one thing up here I'm going to put in the definition, the maximum is like a peak on your graph, and the minimum is like a valley. So with my maxima here, I'm looking for peaks and I'm looking for valleys. So my maxima, in this case it's just maximum, I only have one, that's going to be right here. And so we're going to say that is the point 3, 1. Now that also looks like an interval, but it wouldn't make sense for your maximum to be an interval. It would be a single point. So people aren't going to confuse that, but if you want to emphasize there, you can put the word point. Okay. Now for minima, I do actually have 2 of these, right there and right there. So 1, -1, and then take a guess for, and we'll say 0.5. That's it. Okay. Now, how do we actually, though, find coordinates of a minimum and a maximum? Well, first thing we need to do is we need to find the derivative. So f prime of x would be 12x to the third plus 12x squared minus 72x. And I'm going to set that equal to 0. And I'm going to solve that. So this is a quadratic function, which I don't know how to solve. So I'm going to factor it, see if I can make it into a quadratic. I can factor out a 12. I can also factor out an x. Now, you could completely divide everything by 12 and still get the same answer we're going to have here in a minute. You cannot completely divide out that x because the x is going to get set equal to 0 in a minute. So maybe better just to go ahead and factor it out, and then you can make that indication later on. Okay, factor some more. And then now you would break that apart and set all of those equal to 0. Whether you need to physically do that or not, that's what's happening. So on the left there, I end up with just x equals 0, x equals -3, x equals 2. So here's what's going on. We're going to draw a picture. And the picture is going to have -3 and 0 and 2. And those are the points that we just found there a minute ago. Now, just like we did with increasing and decreasing, I'm going to find out what's going on around these numbers. So I'm going to say plug in a -4. I'm going to plug in, say, a -1. I'm going to plug in a 1, and I'm going to plug in, say, a 3. Now, I'm going to emphasize here that these are my boundaries. Now, we're plugging these into the derivative, which means we're plugging them in here. Now, I'm not going to show the work of doing all that, but I'll write down what I get. F prime of -4, that gives me negative 288. Okay, that's a negative, so I'm going to put a negative symbol right there. Okay, F prime of -1, that gives me a positive 72. Okay, F prime of 1 turns out to give me a negative 48. And F prime of 3 is equal to 216. Now, two things. First of all, you'll kind of notice a pattern, and for the most part, you have more basic graphs here than, say, the other IB math class. So it's pretty much going to go back and forth. If it starts off increasing, the next is going to be decreasing. If it starts off decreasing, the next is going to be increasing, and it's just going to jump back and forth. And that's what happened here. Now, the next thing is that, just wanted to go over those numbers again. Where do the blue and red numbers come from? I just have to pick something within that interval. So the -4, I just needed something on the left of -3. The -1, I needed something between -3 and 0, and so on and so forth. Now, what if I have to have a number, let's say that I'm drawing a number line and I have 0 and I have 1. What do I do there? I have to use a decimal. You have to plug something in between those numbers, and if it's a decimal, it's a decimal. So here's what's going on now. Okay, my graph is going down, and then it's going up, and it's going down, and then it's going up. So right here, this is a minimum because we're going from down to up. This is a maximum, and this is a minimum. Okay. Now, I have to find out, though, exactly what the point is. I want the coordinates, not just where is it. Okay, so I have a minimum at x equals -3. Find it. F of -3. Now, that is this. Okay, we have to go back to the original because I want the point on my actual graph. What's the maximum of my graph? Okay, when we plug that in, we end up with -189. Okay, and that's a big deal. I know it's kind of confusing because we used one equation and now we're using the other one. The increasing and decreasing has to do with the derivative. The actual point on my graph has to do with my actual graph. So if you think of it like that, that should kind of make sense. So -3, -189. Okay, let's go ahead and do our other minimum. We have a minimum at x equals 2. So f of 2 is equal to -64. Now I'm going to write my maximum over here because I've kind of out of space. I have a maximum at x equals 0. F of 0, that's easy to do. That's actually just 0. So I have a maximum at 0, 0. Seems kind of weird that you would have a maximum at 0, 0, but that's what happens. Now, if you have your graphing calculator, you could graph this. But look at that one minimum. It's -189. That's a killer window that you've got to come up with to be able to visualize that. But you could. I mean, you will have a graphing calculator for the entire IB exam. Now, for this test, you won't. But for the actual exam, you will. So you can double check that. Okay. All right. So same thing as this previous section, just adding that last step of finding where those minimums and maximums occur. Okay. Last little part here is related to that. So those were called local minimums and maximums. So even though one of them wasn't necessarily, like, let me go back here for a minute. So here we had 2 minima, but this one was actually the lowest. So when you talk about that, that is what's called an absolute or a global extrema. So it's actually the highest and the lowest point. So that could be an actual peak or valley. Or if you're looking at it over an interval, then it's where like the graph is chopped off, then it's going to be just on that interval. So we'll look at that here in a minute on example 4. But for example 3, we're going to look at all these points and see what they would actually be called. So we have absolute maximum, which is the highest point, absolute minimum, a local max, a local min, etc. All right, so let's see how I put this on my paper here. So let's kind of just go through the list, the order that it has it here. So from an absolute maximum, look at my graph there. What is the highest point? Well, I think that's pretty obvious. That's going to be D. Okay, what about an absolute minimum? Look for the lowest point. That would be C. All right, now a local max. So we're looking for a peak. Well, that would be B. Now, this is not a peak because the peak has to go up and then back down. Okay, a local min, that's going to be a valley. That would be C. And then we come to neither. Well, I didn't write A down for anything, so A would be neither. So A is an endpoint. It's the end of my graph, but it's not an absolute maximum, not a minimum, and it's not a peak or a valley because, again, it doesn't go up on either side. Okay. Now, how does that whole endpoint thing work? So looking at the graph we actually looked at before, I know which ones are my maximums and which ones are my minimums, but now we want to talk about absolute. So we want to go from an interval of 1 to 4. So I'm going to kind of chop off my graph and only look at it from here to here. So what would be the highest point? Well, that would be right there. So that point would be 3, 1. What is the lowest point? Well, that would be down here. So that would be 1, -1. Okay, no big deal. All right, now let's switch it. Now we're going to go from 0 to 4. Okay, so what is now the highest point? Well, before it was right here, but now it would be right there. And let's just take a guess. I'm going to say that's 0, 2.5. So in this case, my absolute maximum is the endpoint. Okay. What about my absolute minimum? Well, lowest point, that would be right there. That answer hasn't changed. All right, now what if we go from an interval of 2 to 5? So 2 to 5. Okay, now I have a peak and a valley within that. I have a peak at 3 and I have a valley at 4, but that's actually not going to be either of my answers. The absolute maximum point would be right here. So 5, let's say 2.5. And my absolute minimum, that's going to be right here. So that would be over 2 up 0. Okay, so again, you've got some questions in your homework that are going to just ask you from looking at a graph to give this information. And then finally, you have an example where they give you an equation and want you to find this information. Now, again, you need to be able to do this without using a graphing calculator. So what I'm going to do is the exact same thing I did in the example on the front. I'm going to find the derivative, set it equal to 0, find when it's increasing and decreasing, and find out what would be my peaks and valleys, okay? Because those could be my absolute max and min. So f prime of x would be 2x minus 2, set it equal to 0, and solve. So we end up with x is equal to 1. Now, we're going to draw our little picture here. So I'm going to plug in a number to the left. I'm going to plug a number in to the right. And this is, again, my derivative. Okay. So when I plug in f prime of 0, sorry. Again, we're plugging it into here. That's going to give me a -2. When I'm doing f prime of 2, that's going to give me a +2. So my graph is going down, and then it's going up. So I have a minimum right there. Now, is that going to be my absolute minimum? I don't know. We're going to check. So as we do this here, we're going to check our minimum, but then we're also going to check our endpoints because that could be where our minimums and maximums were. And just this as an example, okay? So I'm going to now go back to, I don't care, well, no, I do care what the absolute minimum and maximum is because it says to find that. So we're going to go back to the original equation now, okay? So I'm going to do f of 1 because I know that I have a minimum at x equals 1. I don't know what it is, but I'm going to find what it is. So I plug 1 into that. 1 squared minus 2 times 1 gives me negative 1. Okay, so let's see what the rest of it comes out to be. Okay, try the endpoints now. F of negative 1. Negative 1 squared minus 2 times negative 1. That's going to give me a 3. Well, so far it looks like maybe I've got my minimum and my maximum. Try f of 2. 2 squared minus 2 times 2. That gives me 0. Okay, so what's the highest number? Here. What's the lowest number? Here. So my absolute max would be negative 1 comma 3. And the absolute min would be 1, negative 1. That turned out, that was one of my local minima, turned out to be the absolute minimum. I didn't have a maximum, obviously, from my first part of the question there, but my interval turned out to be one of those. Now, we didn't do this on the question here, but if I had thrown an interval into this, we had one maximum here, and we had our 2 minimums here. Well, obviously, only one of those can be your absolute minimum. If we just strictly go on those numbers, it would be this. But if I throw an interval in, if let's say I'm doing in the absolute minimum from negative 1 to 3, well, hey, now my absolute minimum is going to be this one, okay? So we find those possible minimums, and then when they ask you to find the absolute, we just go through now and see which one is the absolute lowest. But don't forget to use your endpoints because that's a common mistake that students do. All right, so this is the last part of this one. The next section, we will throw in some story problems and see some more applications of this calculus stuff.